Good morning, dear students. In the last class, we discussed about circles chapter, and we done 3 problems in the second exercise. Now we'll move to the next fourth problem in that exercise. So, and also assigned this as a homework. I hope many of you did that. So please check what you did is right or wrong. So the fourth question is, prove that the tangents drawn at the end of a diameter of a circle are parallel. Okay, so what we need to do now, so we need to draw the circle and we need to uh, find the solution for this. Okay, suppose this is the diameter. They not yet mentioned what is the diameter measures, so you can take any measurement. Just a minute. So here in this figure, so here in this figure, here AOB is a diameter, that is AB is diameter, and here two parallel, we drawn two parallel tangents RAS and PBQ. These are the two tangents which is drawn at the end of the diameter, that is A and B. Okay, that is end of the diameter, that is A and B. So what we need to prove, we need to prove that these two are parallel, that is RAS is parallel to RBQ. Okay, so how to prove that? We have to prove it theoretically by giving the proper and valid statements and reasons. So how to do that? So we'll do that now. So you may see that in this what is that? AB is a diameter. AB is a diameter. So therefore you can write here AB is a diameter and PQ and RS are the tangents, isn't? PQ and RS are the tangents to the circle. Okay, so then also we know that the radius is perpendicular to the tangent according to the theorem 1. So we know that the radius what we drawn from this from the center to the tangent, so the radius is also perpendicular to the tangents. So therefore OA is perpendicular to RS. So then OB is also perpendicular to RS. If OA is perpendicular to RS, then we can write OAR, angle OAR, which is equals to 90 degree, isn't? So this is 90 degree, this is also 90 degree, all these are measures 90 degree, isn't? All that measures 90 degree. Then so we know that OAR, so here OAR 90 degree, so I wrote that OAR which is equals to 90 degree, and also OAS is also 90 degree. Why? Because it's a perpendicular. And here also the same, OBP is 90 degree, and also there's OBQ is 90 degree. Okay, so all these are 90 degree. So from above what we can do, so you can write that OAR is equals to OBQ. So here this is a alternate angles. Do you know what is alternate angles? Alternate angles which are in Z shape. Do you remember that? The last class in the previous year we discussed about that. So here this also is Z shaped. I'll highlight this. You may see this. Alternate angles are Z shaped. Is it Z shape? Yes. Okay, so here alternate angles are Z shaped, therefore OAR is equals to OBQ. It's an alternate angle, it's a Z shaped. And also this one, OAS. So OAS also equal to this OBP. So this is also alternate angle. So here this is also alternate angle. So Z shaped here also alternate angles. So therefore, since alternate angles are equal, so if alternate angles are equal, you may remember this here. Suppose if we draw a Z shaped here, okay. Suppose this is Z shaped alternate angles, okay. When you draw a alternate angles here, so then what happens if we remove this? If we remove this, what is the shape of? If we remove this line, what is the shape of this? Is it parallel, right? So there also this is parallel. If you remove this line, this is also parallel. So like this we need to explain. We need to give the explanation for this. I hope all of you understood. So if it is alternate angles, then it is a parallel. Okay. So the next problem. Okay. Here the fifth problem I not done. I not did that. So we'll do once the class school reopens. So why? Because we're not able to explain in the online. Okay. We need to explain in the theoretical class. So now here the length sixth problem, the length of a tangent from a point A at a distance 5 centimeter from the center of a circle is 4 centimeter. Find the radius of a circle. Do you remember the first problem what we did is almost same as this. The first or second, okay, the first or second problem option MCQs we don't know, that is the same problem. This type of problems may ask for 2 marks or 3 marks in the examination. So now for this we need to do the diagram first. So diagram is somewhat like this. So what what we need to do here? See what they told you, the length of a tangent from a point A, the length of a tangent from a point A at a distance of 5 centimeter from the center of a circle is 4 centimeter. So from this is 4 centimeter, the tangent length is 4 centimeter, and this is 5 centimeter. So we need to find the radius. It's very simple. So this is a right angle triangle. We know why it is right angle triangle, because yeah, this is perpendicular here. So because this is a tangent, AB is a tangent, AB is a tangent, and which is drawn to the point B. So therefore this is a 90 degree. So therefore in triangle OBP, sorry OB A, in triangle OBA is a right angle triangle. We can write that OA square, which is equals to OB square plus AB square. Okay. So what is OA square? OA is nothing but 5 square, right? 5. OA is 5. So OA square is 5 square. OB is, we don't know, OB square plus AB is 4 square. So here AB is what is that? 5 square is 25 minus 4 square is 16, which is equals to OB square. 25 minus 16 is 9, which is equals to OB square. So therefore OB, which is equals to square root of 9. Why? Because if you take the square root on both sides, here square get cancelled. So here OB, which is equals to 3 centimeters. OB, which is equals to 3 centimeters. Okay. OB, which is equals to 3 centimeters. So that is the radius. Radius, which is equals to 3 centimeters. Okay. So next problem. Okay, here's next question. Two concentric circles are of radii 5 centimeter and 3 centimeter. So find the length of the chord, of the larger circle which touches the smaller circle. Okay, we need to find the length of the chord of a larger circle which touches a smaller circle. We need to find the length of this PA. We need to find the length of this P and A. This PA length we need to find. Okay, so what is the hint they gave for us? They gave us this. This is this is smaller circle. The radius of this smaller circle is OA, that is 3 centimeters. and also they gave us the radius of the larger circle. Two concentric, do you know what do you mean by concentric circles? Concentric circles are nothing but the circle, two or more circle we can draw with the same center. So the center for this circle, bigger circle, you can call it as C2 and this is C1. So both are same, that is O. So this is concentric circle. How many circles you can draw with a one center? We can draw many circles. Okay, so that is known as concentric circles. Okay, now here, so this is okay. Now here, what is PO? PO which is equals to 5 centimeters. PO which is equals to 5 centimeter and AO which is equals to 3 centimeters. Okay, so now find the length of the chord of the larger circle. Find the length of the chord of the larger circle. So we need to find the chord, that is PQ which is equals to how much does it measures, we need to find. Okay, so here also the same thing. So this is a right angle triangle. PAO is a right angle triangle. So therefore PAO is right triangle, right angled triangle, right angle triangle. So therefore if it is right angle triangle, again you can apply the Pythagoras theorem for this. So according to Pythagoras theorem, so here PO square which is equals to PA square plus OA square. So PO square is 5 square which is equal to PA square. So PA square we need to find. So then plus OA square. OA is nothing but 3 square. So now simplify this. 25 minus 3 square is 9 which is equals to PA square. 25 minus 9 is 16 which is equals to PA square. So then square root of 16 which is equal to square root of PA square, taking square root on both sides. So square and square root get cancelled. So therefore PA which is equals to 4 centimeter. PA which is equals to 4 centimeter. Okay, so our PA value is 4 centimeters. Okay, then okay, but but what we want the length of PQ. So therefore we can write here PA, and even if you take this on AQ also same will get. Why? Because here this is 3 centimeter and here it is, this is also 5 centimeter. If this is 3, this is 5, so this is 3, this is a common, so therefore you can take this one. So we got PA which is equal to 4 centimeter. So therefore AO is also 4 centimeter. Why? Because these both triangles are congruent triangles. Can you tell me how it is congruent? We know that. So here this is what is it? PO is same and OQ is also same, and also OA is common. So therefore your PA is same to the OA. That's it. And these two are measure 90 degree. I hope all of you understood this. So then PA plus what is that? AO. PA plus AO is equals to PQ, isn't? So what is PA? PA is 4 centimeter. AO is 4 centimeter which is equals to PA, PQ. So therefore PQ which is equals to 4 plus 4 is 8 centimeter. So therefore the tangent which is drawn is measures 8 centimeters. Not tangent. Okay, it's a tangent for the smaller circle and chord for the bigger circle. Okay, I hope all of you understood. So next, okay, here a quadrilateral ABCD is drawn to a circumscribe a circle. See the figure 10.12. Prove that AB plus CD is equals to AD plus BC. Okay, we need to prove this. So how to prove? a quadrilateral ABCD is drawn to circumscribe a circle. Circumscribe a circle in the sense any geometrical figure is drawn outside a circle and touching all the points here. This is a quadrilateral ABCD is touching all the all the points are touching at the circle here. Okay, a quadrilateral ABCD is drawn to a circumscribe circle. So prove that AB plus CD is equals to AD plus BC. Okay, so now you may see that if you observe carefully, if you take this dr and sr, we can write both are equal. Why? Because from the theorem 2, this dr and sr are the tangents, isn't? So therefore we can write dr is equal to sr. And also even if we take this is a is external point, here sa is equals to ap. And if we take here b is external point, bp is equals to bq. Why? Because these are the tangents. So therefore we can write like this. Here these are the external points. So we know that the tangents drawn from a same external point are equal. So therefore what we can do and what we can write here in the sense, so that is dr which is equals to ds. dr which is equals to ds. Why? Because here what is external, which is the external point? So here d is external point. External point. D is external point. Okay. So then, so next dr is equals to ds. Finish. Then what we can do? So you can write if a is external point. So you can write that. We can write that. Okay. So here d is external point, the tangent drawn from the external point. So d is external point. We can write here dr which is equals to ds. Okay, if C is external point, so you can write here CR is equals to CQ. Why? Because tangents drawn from an external point are equal. We learnt in the theorem 2, and that is important theorem as examination point of view. And here we can write here BP is equals to BQ, and also AP which is equals to AS. So therefore, why? Because it's a tangent drawn from a external point A. So you can call this as equation 1, call this as equation 2, this is equation 3, and this is equation 4. If we add all the equation, add equation 1, 2, 3, 4. If we add all the equation 1, 2, 3, 4, if we add LHS separately and RHS separately, so you can write that dr plus cr. So dr plus cr plus bp plus ap which is equals to ds plus cq plus bq plus as. Okay, so now what is dr plus cr? Here dr plus cr which is equal to dc, right? The length. So you can write this 2 as dc and this 2 as ap plus bp is, so you can here what is that, ap plus bp which is nothing but ab plus ab which is equals to ds. So ds plus as is nothing but ds plus ds plus cq is there, right? Okay, ds plus cq is there, but we're not able to write this. So what I'll do, I'll rearrange this. So how I'll rearrange? So I can write here ds plus, here as is there, I'll replace the as here, as plus bq is there, write that bq as it is, then plus cq. If we rearrange the places, there is no changes in any values. So now here here CD is there and AB is there. I'll again rearrange this according to the question, according to what we required. AB plus here CD and DC both are same. I'll write here CD. So here DS plus AS. So DS plus AS is, we can write it as AD, or so what is the DS plus AS? DS plus AS. We can write it as AD. Yes, we can write it as AD plus BQ plus CQ. BQ plus CQ we can write as BC. Okay, so therefore AB plus CD, which is equals to AD plus BC. AD plus BC. Okay, this is the proof. I hope all of you understood. Okay, the remaining problems we'll do in the next class. So copy all these problems in the classwork. Okay, thank you. Have a nice day. Bye.